straightforward way. Okay, so I want you to be clear that that's the whole idea behind step functions. So that's nice for step functions. Now let's look at something more complicated. The next level is what is called a ramp function. This represents jumps in slope. So definition is the following. It is written as x minus a, so alpha times x minus a to the 1. So this is jump in slope jump in slope times x minus beginning value and then power tells me straight line. Which means this function looks like this. Let's try some example to see if we can work this out. Let's try some example to see if we can work this out so that we can get used to doing these kinds of computations. So let's see. I have something, example number 1 is this, very simple one. It's just linearly increasing like this. Starts out at x equal to 2 and ends and then keeps going all the way up. The slope is actually 2 units. So then this will be 2 times x minus 2 to the power 1. So this thing goes here, this slope goes here. So I hope you got the idea. So let's try something more ambitious. Now I want to try like that, like that, like that. So this is at x equal to 0, x equal to 1, x equal to 4, this height is 3 units. Well, how do we do this? So I'm going to draw this in red so you can see that's the initial slope, that's the next slope, that's the next slope. So if I draw it like that, you can see jumps in slope, this one that goes like this, there's another one that goes like this, and then I'm going to draw. So it's like playing Donkey Kong or something like that. You know, you have to know how much you're going to jump by. That's all there is to it. So let's play that. So our game is very simple. I start out at x equal to 0. So q of x will be at x equal to 0, it's just 0. And then at x equal to 0, no jump in value. Slope jumps by how many units? Let's see. Initial slope was 0 and then slope jumps to what value? Let's see. It jumps to 3 over 1, so this slope is 3, so jumps by 3 units. Then at x equal to 1, no jump in value but slope jumps by, let's see, what's this new slope? This is 3 units, so this slope is minus 1. So it went from 3 to minus 1, so it jumped up by minus 4. And then at x equal to 4, no jump in value, but slope jumps by. From minus 4, it goes back to horizontal, so the jump on slope, sorry, from minus 1, it goes back to horizontal, so the jump is 1. I want you to understand, notice 3 minus 4 plus 1 is 0. So the total starts out at horizontal, ends up at horizontal. So all the jumps in slope should better add up to 0. because it starts out horizontal and ends up horizontal. Okay, so that's why it's a truncated chunk, just a chunk of function between two values. Outside these two things, it's all 0. So what happens is, I will get this thing is written as 3 times x minus 0 to the power 1 minus 4 times x minus 1 to the power 1 plus 1 times x minus 4 to the power 1. So these 3 numbers show up here, here, here. These 3 numbers would show up here, 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 and okay. Now let's try something a little bit more ambitious. I want you to try it. Okay, so this is 1, 2, 3, 4, 5. So this is 5. And this is 1, 2, 3, 4. So this height is 4. This is 1, 2, 3, 4, 5, 6, 7. So this distance is 7. And this height is 1, 2, 3, 4. 4. This height is 1. Point is at 1, 2, 3. And then this point is at 1, 2, 3. Right? So you can actually look at the graph and you can figure out what the heights are and where the units are. So the question is, can we represent this function? Okay, let's start. I start out at 0, so I'm walking along, so I'm the Donkey Kong, I go up here and I say, I come up here, I say, oh, the slope has suddenly increased. By how much? It went up, let's see, 1, 2, 3, 4, 5, so this distance is 5 and the height is 4. So it went up by 4/5, so I'm going to write it as 4 over 5 times x minus 0 to the power 1, that's this chunk. Then I go all the way up here and I say, oh, there's another jump here. How much did it go? It went from 4/5 all the way down to 4/3. Can you see this height is 4, this distance is 3, right? 4/3. It went down by 4/3. So from 4/5 it went down by 4 to 4/3. So the height will be 4/3 negative minus 4/5. That's how much the slope changed times x minus, let's see, that's at the location 5. So x minus 5 to the power 1, which turns out to be how much? 4/5 minus, so this, if I add these two things, the common denominator is 15, 20, 4 is 12, 32 over 15. So this is 32 over 15. The jump is 32. In all these calculations, it's actually quite useful to write down the slopes of these different things, because then it's easy for you to say, this is 4/3, and then this one was minus 4/5, and this one is again 4/3. So what happens is, the next one turns out to be the reverse of this. 4/5 plus 4/3 is how much it jumps by, times x minus, what is that? 7 plus 5, 12 to the power 1. And then the last jump is from 4/3 to 0. So minus 4/3 times, so it went 4/5, then 4/3, then minus 4/3. Right? So minus 4/3 and x minus 12, 30, 40, 15 to the power 1. That's all there is to it. So what it is that at every time, just walk along, and whenever you see an abrupt change in slope, you have to account for it. That's all there is to it. Okay. Now, let's get really ambitious, and this time you have to try. I got this. Here, and I'm going to pick this dimension as 4 units. Then I'm going to pick this location as 4 units. Then this one as another 4, and this one as another 4. This dimension, this height as, no, let's pick 6 units. Okay, so immediately that tells me that this slope, how much is this slope? That slope is 4 by 4, so that's -1. That slope is -1. The slope here is 0, and the slope here is 6 over 4. That is 3/2. Okay, this is our forcing function. This is what it looks like. So off we go, and we can write this. You will see that you have to be careful. So please take a look at this. What I want you to do is to pause and try this by yourself. Then you can come back and take a look at my solution. Okay? Good. So did you pause? No, you try and watch this. So I want you to remember that the aim of this, students always want to see us work out all the problems, but we want you to learn. As I keep telling you, that it is ultimately supervised practice with feedback. So our job is the supervision and the feedback. It's your job to practice, right? And since this is a video type deal, I cannot really help you practice. So you have to have the self-discipline to actually pause. So pause this video, try it out by yourself. That's the true test of whether you figured it out or not. Then you can come back and watch it. Okay? So pause now. Good. So let's see whether you got what I got. I started out and I said, I am the monkey in the Donkey Kong or whatever it is. So I'm coming around here. I say, there is a jump in value. I have to start out from horizontal and jump up by 4 units. Wow. So that's 4 times x minus 0 to the power 0. Then I'm going to say plus. Then I have jump. When I get up here, I also have a jump in slope. Not only a value, but jump in slope. Can you see that? My slope goes from 0 to -1. So I have -1 times x minus 0 to the -1. Sorry, to the 1. So that's my line that goes down like this. I come up here at x equal to 4 and I say, there's no jump in slope, but there's a jump in, sorry, there's no jump in value, but a jump in slope. It went from -1 to 0. So I get plus x minus 4 to the power 1. I come up here and I say, there's no jump in value, but another jump in slope from 0 to 3/2. So I get plus 3/2 x minus 4 plus 4, 8 to the power 1. See how this works? Make sure you figure out how this works. Notice that in the beginning, I have to be careful. I got to get all these jumps in value done straight. Okay? This is really important. If you don't do it, you'll get into a mess. So you should always start out assuming that you are going horizontally along the x-axis until you hear the first jump. Then after that, you can do whatever you want. But that first step is really important. If you get that right, things will work out. Okay, so I want you to try another one. This is a little bit more ambitious. So this is my x-axis, and I go down like this, then I go down like this, and come up, then I come down, and then I do this. Let's pick some numbers. This 8 units. This is 4 units. Okay. This height, this much is 4 units. This height is another 4 units. This is another 4 units. This is 4 units. That's 4. Okay, and then what else do I do? This jump, this height is 1. Okay, so again, pause, you try it out yourself, and then we can come back and we can do it. Okay, so pause now. Pause, good. So, okay, so you have tried it, I hope, and I'm going to show you what I got. You may argue with me, and that's fine, and that's a good thing. So I want to make sure that I get it right. And by the way, you know, I am human, so sometimes I make mistakes. So if you find a mistake, let me know, so because then I can redo that portion of it. Okay, so I got this. So let's see. I started out, and there was a jump in value of 8 units. That's the jump in value. The next one was jump in slope. The slope is, when I come up here, what's the slope of this? That's -2. You see that? And the slope of this is 4:4. The slope of this is 1. So if this is 4, this height is 4. So this jump, so this value is 1. That value is 4. And then the slope here is 0. Okay. It's always a good idea to mark all the peaks, all the sharp points, because that's where all the transitions will occur. You have to mark all the transition points. So you have to mark the displacements. What I mean by that is heights, and you have to mark the slopes. That's the minimum. Okay. So if you do that, you get 8 times x minus 0 to the power 0. Then you got -2 times x minus 0 to the power 1. So I got down here, now I am at 0.4, there, I jumped down by how much? By 4 units, so I got -4 times x minus 4 to the power 0. My slope went up from -2 to 1, so I get +3 times x minus 4 to the 1. It's just a game, so just play this game. This is very useful because you can write all kinds of complicated functions and singularity things. This is beautiful, this is an amazing thing. And all it is just a silly game. So just play it. Okay, 3 times x minus 4 to the 4, and then let's see. So we are here, and then nothing happens at this point. So if you wrote something here, you are wrong. Nothing happens here. There is no jump in value, there is no jump in slope. Things are nice, so we ignore it. At this point, there is a jump in value. It went from 4 units to 1 unit. So I had a jump in value of -3 units. X minus, so 4 plus 4, 8 plus 4, 12 to the power 0. And then I also had a jump in slope. It went from a slope of +1 to a slope of 0. So I got -1 times x minus 12 to the power 0, to the power 1. Sorry. So notice these are the jumps in slope. And you can see that if I add the concentrations, then you will get exactly 0. -2 plus 3 minus 1. So if you add those 3 things, you get 0. So if you started out with 0, I ended up with 0. See what I mean? That's the whole idea. Okay. So you can do this for all kinds of functions. In fact, you can also do higher powers, but they are less useful. The most useful things are the step function and the ramp function. Okay. And 2 more things that we will find, especially for beam problems, these will be extremely